Hello, my name is Justin Castillo, and this is my submission for Programming Assignment 5. So first off, we check the number of arguments passed. We grab the number of frames and check that it's between 1 and 10. We go through the file and grab the pages and put them inside the pages dynamic array. And then we check for errors, check that there are indeed references inside the file. For the first in, first out implementation, we count the number of faults. We have an array of a dynamic array for FIFO that's initialized to -1. And then we go through the page array, and we check that the current page we're trying to insert is not already in there. If it is found, we basically do nothing. If it's not found, that's a page fault. Then we put the page inside the FIFO frames array, and then post increment our filled count, our filled index. And then if it's not full, if it is full, then we put it in the next to replace index, and we increment that with a circular modulo, so it goes on forever, and we count that as a fault, and we keep going until that's done. And then for LRU, we have two parallel dynamically allocated arrays, LRU frames and last used, that we initialize to -1. First off, as we're going through the pages array, if it's found, then we update found index. If it was indeed found, then we update the time that that index was used in the parallel array to the current I, which is the timestamp. If it's not in there, if the number of items that were filled is if it's not full, basically, then we go ahead and just insert it. We update the time of the newly inserted process, and then we increment the filled index. And then if it's not full, I mean, if it is full, then we get the smallest value in the last used array, and we get the index of that, and we place the page at that index, replacing the least recently used process or page, and then we update that time to the current I, and we count that as a fault. We go through all that, and here we just print out the results and free up all the memory. So I'll go ahead and run this. This is just the example from the lecture. And as you can see, it does give the correct answer, 15 faults for FIFO and 12 faults for LRU, with ending at 701 and 107. I kind of went through it by hand again here just to make sure. And comparing the two algorithms, the least recently used algorithm is friendlier to processes or to pages that are used frequently. So it's more likely that it's going to be kept inside the frames, and thus results in less page faults than first in, first out, which is indifferent to the the frequency of a page's use. So I did use Gemini this time just to clarify concepts. I got the concept, but I had some difficulty understanding how to implement it. I wanted to do like structs, where it was like an array of structs that kept track of the page, and then the status, like the time that it was last used. But I just found this to be a little easier. Yeah, and then what else? I believe, yeah, so this definitely matched my expectations. yeah, I think that's it. Okay, thank you for watching. Appreciate it.